the two methods that we used were the disk and the wash. For both of those, the rectangle was always perpendicular to the axis of revolution. Now, there are times when it's easier to have your rectangle parallel to the axis of revolution, and that is going to use what's called the shell method. Now, for all of high school, when I was taught this, I envisioned shell as like a seashell, and I did not understand what was going on, and it really literally was not until I started teaching this class that I realized that the shell method has nothing to do with the seashell, but it's just like a casing, like almost a shotgun shell. Like a shotgun shell is like a casing around gunpowder. Okay, so that's kind of what you have to think about. So what we're going to do is we're going to consider a representative rectangle as shown in the figure, and that representative rectangle is like right here. This is not, it doesn't copy very well, but this is in your book in section 7.3, where W is the width of the rectangle, so like basically the thickness of that rectangle, and then H is the height or the length of that rectangle. And then P is the distance between the axis of revolution and the center of that rectangle. So P actually goes from the axis up here to like halfway between W. So P is the distance from the center to like halfway through the thickness of that shell. And then when that rectangle is revolved about its axis of revolution, it forms a cylindrical shell or a tube with a thickness of W. So the outer radius of this shell is going to be from the axis of revolution all the way to the outside of W. Well, if P goes from the axis through half of W, then what would the entire radius be? Good, P plus 1/2 W. What would the inner radius, or the radius of the hole, be? Good, P minus 1/2 W. Because by definition, P goes from the axis not to W, but halfway through W. And the reason that they basically defined the variables like that so that the formula would end up being nice. Like these variables right here don't seem very nice, but in just a second, it's going to be a nice, easy formula. And that's why they defined it like that. Okay, so the volume of the shell, we're going to do the same thing. We're going to take the outer volume and then subtract out the whole. Once again, it's a cylinder, so the volume of any cylinder is pi r squared times h. So I'm going to take the outer part, outer volume, minus the inner volume, or the whole. So the outer volume is going to be pi, and then the radius is P plus 1/2 W. Have to square the radius and then times h. And then the volume of the whole is going to be pi r squared, but the radius of the whole is P minus 1/2 W, the quantity squared, and then multiply times h. So I could factor out a pi and an h, and then I would have P plus 1/2 W quantity squared minus, P minus 1/2 W, the quantity squared. Now, to simplify all that, we would have to FOIL out both of these two parentheses that are being squared. If you FOIL both of those out and combine all of your like terms, then you get something that is very simple, and you get P times W times 2. So P W times 2. I should have probably put the 2 in front. So basically, this whole bracket right here, if you were to FOIL that out and combine all of your like terms, you're going to get 2PW. So I am going to rewrite this as 2 pi P, H, and W. And the reason I'm going to rewrite it like that is because W is the thickness of that. So what happens is that W turns into your variable of integration. And what we're going to do is we're going to take 2 pi as a constant, and then we're going to integrate pH, and then with respect to either x or y, depending upon whether or not that thickness is an x or a y. This right here basically just shows you your 2 different types of formulas depending upon whether or not your rectangle is horizontal or perpendicular. So the biggest thing is that your axis of revolution here is horizontal, and to use the shell method, that rectangle has to be parallel to that axis of revolution. So the volume is going to be 2 pi, and then the integral of the length of the rectangle, which is h, times p. And remember that p, as defined above, was the distance from the axis of revolution to the middle of that thickness right there. And then if you were going to revolve this region around a vertical axis of revolution, then you would need a vertical rectangle. So you're still going to integrate 2 pi. H is still the length of the rectangle, but P is going to be the distance from the center, from the axis to the center part right here. And then on the bottom there is just a picture of what would happen if you rotated that through. So a couple things here is that your rectangle is always parallel to the axis of revolution. So the length of that rectangle, h, is always parallel to that axis of revolution. That's a good way to think about it. And then P, and this is going to make more sense when I work a problem in just a second. P is the distance from the axis to the middle of the width of the rectangle. Okay, so what we're going to do is we're going to find the volume of the solid that's formed by revolving the region bounded by y equals x minus x cubed and the x-axis between 0 and 1 about the y-axis. So the first thing you want to do is get a picture of what does that region look like. And if you draw the graph of y equals x minus x cubed, then you get a graph that looks something like that. But we just want to take the portion between x equals 0 and 1 and the x-axis, which happens to be this little portion right here, and we want to revolve it around the y-axis. So we're revolving it around that. Okay, so if we were doing the disk or washer method, your rectangle has to be perpendicular to the axis of revolution. So the rectangle would have to be right there. And the length of that rectangle would be the right side minus the left side. But what do I have to do to the equation when I have a horizontal rectangle? Solve, right, solve for x and put it in terms of y. Can anyone think of an effective way to solve that equation for x? It's impossible. You can't do it. So that's why this method, we have to use the other method. So because we can't do a horizontal rectangle, I'm forced to do a vertical rectangle. And now that rectangle is parallel to my axis of revolution, which means I have to use the shell method. All right, so the formula for the shell method is 2 pi integral of pH, and because I have a vertical rectangle, the width of that rectangle is like an x, so I'm doing dx here. Okay, so P It's weird. I think of it in terms of pH, but then I always identify H and H first. H is the length of the rectangle. So what would the length of that rectangle be? Right, top minus bottom, which would be x minus x cubed, technically minus 0. Yeah, the dx would be like dw. It's dx because the width of that rectangle is an x value, not a y value. All right, so h is really just x minus x cubed. All right, p. P is the distance from the axis of revolution to the middle of any one of those rectangles right there. Well, no matter where I place this rectangle, I can call the middle of that some x value. And that's kind of the hardest part, is just being able to visualize that the middle of that rectangular width is just some x value. Because it doesn't matter where I draw that rectangle in the figure, but the middle of that is just some x value. So what is the distance between the y-axis and this value x? It's x, right. So p is just plain old x. Whoa, crazy pen. So I'm going to take 2 pi, and I'm going to integrate p times h, which would be x times x minus x cubed dx. Now, between which two x values do you think I'm going to integrate? 0 and 1. And if you were to type that into your calculator, you would get 4 pi over 15. Okay, just for fun, I'm going to show you how p changes if we change our axis of revolution. Let's say that I want to revolve around x equal negative 2. Okay, so if I'm revolving around x equal negative 2, my h is still the same. The height of that rectangle has not changed. But p, which is the distance from the axis to the middle of that width, which I'm calling x, the p is going to change. What is the distance between the vertical line x minus 2 and x? X plus 2. Because remember that when we were going over that quiz, I said always, 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 anytime you're trying to find a distance, you either do top minus bottom or right minus left. So if I do right minus left, the right side is x and the left side is negative 2. So x minus a negative 2 would be x plus 2. Okay, what if let's do one more. What if I wanted to revolve around x equal 5? So what would the distance between x equal 5 and x be? 5 minus x. Literally the right side minus the left side. Now, had I been revolving this figure around a horizontal line, then the disk or the washer method would have been a good choice, right? Because I could still use my vertical rectangle, but it's perpendicular to the axis of revolution, so I have to use disk or washer. Find the volume of the solid formed by revolving the region bounded by the graph of x equals e to the negative y squared and the y-axis between 0 and 1 about the x-axis. Well, how on earth am I going to graph x equals e to the negative y squared? In terms of y? Let your calculator do it. Can you graph x equals in your calculator? Yeah, take the natural log of both sides. So the natural log of x, what's the natural log of e to the negative y squared? Negative y squared. Or y squared would equal the negative natural log of x, and y would equal plus or minus the square root of negative ln x.